Welcome back to Tezos X-Plained. Today, we're going to talk a little bit more about RISC-V. Last time, when we were talking about RISC-V, we really actually focused at quite a technical level on the specifics behind why we sort of made this decision to shift away from WebAssembly and towards RISC-V.
Yeah.
So today, I was hoping to talk a little bit about how that actually, down the line, really affects the user experience and the developer experience behind Tezos X.
Right.
So developers should be able to use whatever tooling they feel most comfortable with.
Mm-hmm.
So, if you are a JavaScript developer, you should be able to use JavaScript. If you're an Ethereum developer, you should be able to use Solidity. And indeed, we have sort of started the roadmap for this. We have Etherlink, TezLink, and then lastly, we have Jstz. How does Jstz differ a little bit to the sort of offering that Etherlink and TezLink gives?
So, TezLink is trying to be Tezos. The idea being you want the tooling for Tezos to work out of the box for it. The wallets, the explorers, it may be a little bit of tricks here and there, but essentially it is like using Tezos. It has same APIs. Same thing with Etherlink. Etherlink is trying to stick as close as possible to Ethereum. Every L2 that has tried to emulate Ethereum has tried to do replicate the API, all of that. Jstz doesn't have this constraint, so Jstz is based on JavaScript. It's not trying to be anything else. And as a result, it can free itself from some of the constraints that blockchains have. And in particular, it doesn't have a concept of blocks, right? You only have a series of transactions that happen, contracts that change their states, HTTP-like calling convention between contracts. So it's a very familiar environment for people who've done web development.
So would it be fair to say then that Jstz, in a sense, gives a sort of more open sandbox for developers to play with versus, say, Etherlink and TezLink?
I don't know that it's more open. I think it's really is designed by the ground up for replicating the experience of building for the web. And so in that respect, perhaps what you mean by that is you can bring in JavaScript libraries, you can bring in JavaScript toolings, you can use all sorts of things that you would use as opposed to having this very bespoke ecosystem where you don't have the richness of a very, very wide set of libraries, projects that have been built around it.
Absolutely. You're less restricted in the sort of tooling that you choose because you should just be able to take the tooling that you're comfortable with, that you're used to, that you're good at, and use that to write code for Tezos X.
Absolutely.
Now, there is a little bit of a distinction here that's perhaps worth making in that Jstz, while it is a little bit more open in the tooling that you can bring to it, it is still highly restricted, actually. Currently, kernels, the programs that ultimately run on our rollups, they are, in effect, runtimes for code. So for Etherlink, the kernel is a runtime that gives the interface to the EVM contracts what they would expect out of any sort of Ethereum or EVM-based chain. And similarly for TezLink, the contracts expect this sort of runtime, that is the runtime of Tezos for Mikkelsen, to exist correctly. This can be a bit restrictive in the long run. So something we've talked a lot about is wanting developers to be able to bring any tooling at all. So while obviously if you are a JavaScript developer, you'd fit very, very well into Jstz, and I'd absolutely encourage people to try it out. But Jstz does nothing, for example, for a .NET developer.
Yeah.
Now, down the line, whenever we have sort of support for a new language, do we always want to be introducing this like new runtime for that language, or is there something else we can do?
Well, I think there's different ways to go about it, but definitely the goal for Tezos X is to support a majority of mainstream programming languages. I think one good target is that there's these websites that look at projects on GitHub, and they will tell you like 26% is C and 12% is Python or whatever. And, I say if you support enough languages that you cover 50% of the repos on GitHub, you're in a good space.
Yes.
All right. One approach, a very radical approach, is you just say, you know what, we'll just have a Linux environment. And, if people want to, whatever that they're running on Linux, they can just run here because they can bring a compiled executable that is the runtime for their interpreted language or a compiler for the language and just run that.
Absolutely.
That's a very, very open approach. There's some difficulties with it in terms of you don't actually want to replicate a full Linux system because it's very, very wide. You don't want to be in a situation where every time there's a 0 day in Linux and those happens, you end up with something that can compromise the security of the rollup, right? You still want a lot more security than that. So there's something a bit in the middle where you have sort of a Unix-like environment. It has a lot of the APIs, maybe not all of them. And then you support languages by having a dedicated runtime for each language that you want to support. So you could have Python, JavaScript, .NET, Java, You do that, you're already in really good shape.
Yes, absolutely. This Linux environment that you mentioned, I think it becomes a really, really good compilation target for these various runtimes.
Yeah.
And it's something that we are really pursuing within the sort of RISC-V work that we do, precisely because we want the platform to be as accessible as possible to as many developers as possible. The Linux syscall interface becomes a really, really solid target. We benefit there a lot from the work of like Linus Torvalds in insisting that user space never breaks, which means that we have this incredibly stable API.
Yeah.
And we can choose absolutely which bits we implement out of that. So that absolutely allows you to bring all these other tools across.
No, I mean, that's very exciting. Are we going to have like systemd, for example, all of that implemented as part of this?
I think the really important distinction is that between user space and the kernel.
Right.
So for developers, for those writing programs for Tezos X, they are always in user space.
Okay.
So the initial approach that we took with RISC-V, and we touched on it a little bit last time as well, is that we just wanted to implement really only what was required for the CPU from like the RISC-V specification.
Right.
And that meant we had to implement all the different user modes. So obviously user mode, but then also supervisor and machine mode. And Linux kernel, for example, will run at supervisor mode most of the time, a little bit at machine mode as well. And these are all privilege levels. So we really want to make sure that programs that get deployed on Tezos X are only in the sort of user space and can't sort of, as you mentioned, like a 0-day in the Linux kernel, that could lead to one program interfering massively with another runtime. And we really do want to avoid that. So initially, because we took this approach, we bundled all the programs, the kernels that we were running with a kernel called Hermit OS that gave the sort of unikernel, allowed you to bundle everything and run this. But we are moving away from this approach towards this Linux ABI, but we are not doing it by deploying Linux itself in our rollup.
So it's not just a matter of saying like, well, you know what, I can compile Linux to RISC-V. So there you'll go, I'll take my Linux distribution, compile it for RISC-V, and then run that, and then people can run on top of that.
Exactly. We're not doing that.
Okay.
For a couple of reasons, and one of them is that these deployments become massive. The Linux kernel is obviously quite large, and you don't want replication of work. Every single tool that a developer wants to use, you don't want to have to bundle the Linux kernel again with it. We move into the situation where actually the RISC-V interpreter that we have, it's no longer just the interface of a CPU. We are actually implementing the interface of the supervisor. So the system calls that we decide to support, the RISC-V interpreter actually implements those ABIs directly. And that allows us to be very precise about what we decide to support.
Yeah.
And we also target a slightly reduced API of a pure Linux. We actually are targeting the API for musl. So it is a little bit reduced in terms of what programs actually expect of the host as well.
Okay. Is this like an operating system? Are contracts going to have files, set file permissions, interact with processes?
Exactly. Like we actually do want to move towards this. Processes, a really nice abstraction for parallelism as well, in terms of communication between programs. You mentioned the file system. And actually, rollups always need a durable file system. We have a file-like API for the WebAssembly runtime, but it doesn't quite work like a file system. You have to use specific calls from the Rollup SDK. You can't just use, for example, your standard libraries file system tooling.
For most blockchain, it's not really been a file system. It's been more like an object store.
Yes, exactly. So that's currently what we have, but when you want, for example, to use libraries out of the box that expect the file system to be there, and we are already implementing the Linux syscall ABI, it makes a lot of sense for us to actually expose storage as a file system.
Would it make sense to expose something with a SQL interface as well, for instance? Like have like database running in the background and say, hey, you can actually create a table here, call it.
So that's a really interesting question. And I suspect that this isn't something that would ever exist sort of natively within the RISC-V runtime.
Yeah.
But because it is just Linux,
right,
or looks like Linux, you could absolutely deploy a SQL database and interact with it directly. So I think that's kind of like a really nice summary of where we see Tezos X in a way going and how like RISC-V enables that. It should look like Linux. It should feel like Linux when you're developing on it. And everything compiles to that and runs with that infrastructure.
Very cool.
Amazing. Well, thank you very much.
Thank you.